Hello and welcome to another video for pre-calculus. In this video, we are going to talk about system of linear inequalities and linear programming. So you are used to with the equation. So any statement written in this form ax plus by equals c is an equation. And then when we graph that, what we get for an equation is we'll get a line like this. And then and all the points on the line are the solution for that equation. Okay, so that's what we did with the equations. Now, when it comes to the inequality, inequalities can be written in any of these four forms. So we have ax plus by is less than c, then we have ax plus by is greater than c, and then we have ax plus by is greater than or equals to c, and ax plus by is less than or equals to c. Now, when we graph a linear inequality in two variables, so the solution or the graph of that inequality would look like something like this. So we'll first graph this line. So we have ax plus by is less than c, but what we do is we'll take this inequality and we'll change this one into an equation. So we'll write ax plus by equals C. And then that's called a boundary line. Um, so we'll grab this line. If we have strict inequality like this, less than or greater than, then when we draw the line, we draw a dashed line, okay? But when we have inequality with equal sign, like this, when we draw the line, we'll draw a solid line. So what we do is we'll take that equation and we'll draw that line, and then our solution would be either on this side of the line or the other side of the line. So the solution of an inequality consists of infinite number of order pairs. Okay, so there's so many order pairs that are the solution to the um, inequality. And then it's not just the points on the line, it is a region or it's an area which is the solution to the inequality. So now next we'll look at some examples. We'll graph the inequality and then we are going to share the solution set for the inequality. Yeah, let's go ahead and look at an example. So here our inequality is 3x minus 4y is less than or equals to 12. So first what we do is we'll go ahead and graph this line. So you can do this in a couple of ways. So you can just change the equation in the form y equals mx plus b, and then you can grab the line. Or instead of doing all of that, what I would like to do is I'll find the x and y intercept for this line. So to find x-intercept, we make y 0. So this becomes 0. Okay. So when that is 0, the x-intercept is, so we get the equation 3x equals 12. So the x-intercept is 4. So x-intercept is 4 comma 0. Similarly, we'll find the y-intercept. So when we find the y-intercept, we make x 0. So when we make x 0, this term is 0. So we have negative 4y equals 12. And then the y-intercept is negative 3. So once we have x and y intercept, we'll just go ahead and grab those intercepts and we draw that line. So x intercept is 4 comma 0, which is right here, and the y intercept is 0 comma negative 3, which is right here. Now we'll look here. This inequality has equal sign as well. That means we'll draw a solid line. If this was a strict inequality, we'd have drawn dashed line. Okay, so now let's go ahead and draw that line. Um, Make sure we draw a straight line. Sorry, that's not a straight line. Let me draw a straight line from here. And then like this. Okay, so now in order to figure out whether the solution is above that line or below that line, which region is the solution, what usually we do is we'll take a point, which is called the test point. So we'll take a test point. Okay, so you can take any point on the graph as the test point. Just don't take a point on the line. Okay, so we can pick this point or this point or this point, any point on the graph. Usually if the line is not passing through the origin, I would like to pick the point 0 comma 0 because that's the easy point. Okay, 0 comma 0. So we'll take that point and we'll test. That means we'll put that point on this inequality. So the test point is 0 comma 0, and I'll plug it into this inequality. So 3 times 0 minus 4 times 0 is less than or equals to 12, which gives us 0 is less than or equals to 12. And this is a true statement because 0 is less than 12. That means we can include this point in our solution set. Okay, if the statement is true, that point is included in the solution set. That means the solution is above this line. If this was false, then that would be on the other side of the line. So we don't include that point if it was false. So it would be on the other side of the point. So everything above that line is the solution to this inequality. And then we'll just go ahead and share that region. Okay, so we'll just share this. So this is the solution for this inequality. So any points from this shaded region, if we pick that point and if we put it on that inequality, it satisfies the inequality. Also, since this is a solid line, we also include the points on the line. They are also part of the solution. Now let's look at another example here. So that one was just one inequality. Now, how do we graph the system of inequalities, or how do we represent the solution for a system of inequalities? So it's very similar. We just go ahead and graph this one, and then we'll take the common region as the solution. So let's go ahead and do this. So let's go ahead and graph the first line. For this line, let's see, let me write it here. Okay, so the x-intercept for that line is when y is 0, so we get x plus 4 equals 0, and that gives us x equals negative 4. So x-intercept is negative 4 comma 0. And the y-intercept, we make x 0, so we get 2y equals 4, and divided by 2, we get y equals 2. So that means the y-intercept is 0 comma 2. So that line, the first line, is negative 4 is the x-intercept, and then 2 is the y-intercept. Okay, and then let's go ahead and draw the line going through these 2 points. So yeah, that's how it's going to look like. We'll extend this. Now let's go ahead and grab the second line. So this is x is greater than negative 3. So the line for that one, the boundary line, is x equals negative 3, which is a vertical line. But here we have this inequality, strict inequality, so we don't draw the solid line. We'll draw dashed line for that. So it's the line x equals negative 3. So it's this vertical line going through negative 3. So that's x equals negative 3. Now, let's go ahead and check the first one. Okay, so the first one, if we take the test point, we can take any point that is not on the line, but again, it's not passing through the origin. So I'll take the test point as 0, 0, and I'll put it into my inequality. So 2 times 0 is greater than or equals to 0 plus 4, and that gives us 0 is greater than or equals to 4, which is false. That means we cannot include the origin in the solution for the first line. So it has to go away from that point, so on the other side. So it is above this line in this direction. Now similarly, if we take a test point and test that for the second line, so second line is x is greater than negative 3, and we can take this point. So if we put 0, so 0 is negative, 0 is greater than negative 3, which is true, or it basically says x is greater than negative 3, so it's on the right of that one. Okay, so in this direction. Now for the red line is above that line, for the blue line is to the right. So now the solution for the system is the common region. So here the common region for both is this region right here. So this is the solution for this system of inequalities. So this region is above that red line and to the right of the blue line. So that is the solution. So if we pick any point from that shaded region, and if we put it into our inequality, both the inequalities will satisfy. Okay, Now let's take more than two equations. In this one, we are going to graph this one, and we are going, so it will give the solution set, or which is also known as feasible region, will give us a shape, and we'll just write the coordinates of the vertices. Okay, so for the first line, the x-intercept is, if I make y 0, I get 2x equals 12. So the x-intercept is 6 comma 0, and the y-intercept is, if I make x 0, I get 3y equals 12. That means the y-intercept is 4, so we have 0 comma 4. So x-intercept is 6, here y-intercept is 4, and let's go ahead and draw that line. Let me draw this straight line from here, sorry, let's go this direction. I don't know if I draw the straight line. Okay, I think it's a straight. Okay, it's very important that we draw a straight perfect line, because we are going to look at the vertices. So for this second one, for this one, the x-intercept is, when we make y 0, you get 2x equals 2, and the x-intercept is 1, so 1 0. For y-intercept, if we make x 0, we get y equals 2, so the y-intercept is 0 2. So now let's go ahead and graph that. 1 comma 0 is right here. 0 comma 2 is right here. So what I'm going to do is I'm going to draw a line, straight line from here. I don't know where it goes. It's not a straight line. This is very important that we draw the line perfect. Okay, so I messed up with this one. This should be a line here, and then this should be a line here. It's really hard to draw that in this screen. So, okay, I'll just leave it there. Okay, so now it's really hard to draw that in the screen, a straight line. So this one, x is greater than or equals to 0, is the line right here. So x equals 0 is the y-axis, and then it's greater than or equals to 0, so it's on this direction. Similarly, y is greater than or equals to 1, so the line is right here, y equals 1, and it's above that line. Now for the purple line, okay, so for the purple line, let's see, let's go ahead and check. So the purple line is this line. If we take the test point 0 0, okay, so if we take the test point 0 0, we get 0 is greater than or equals to 2, which is false statement, so it cannot include the 0, so it has to go away from there, so it's in this direction. Okay, and then for the blue line, if we take 0 0 and test, we get 0 plus 0 is less than or equals to 12, which is 0 is less than or equals to 12, so it's in this direction. So we include 0 0, so it's in this direction. Now if we look over here, okay, if we look over here, the solution is the region bounded by these 4 lines. Okay, so the solution is in this region right here. So this is the solution right here, because it is to the right of the y-axis, above the line y equals 1, and below that blue line, and to the above that purple line. So that is the solution set. Now we have a shape here, which is a I think it's a pentagon, and then we need to write the coordinates. Okay, so the coordinates are here, 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 and here. So these are the coordinates, are the vertices. Sorry, vertices. So the vertices are, so the first one here is 4.5 and 1. So 4.5 and 1. This one looks like 0.5. I'm not sure. We'll just guess. Okay, so 0.5 and 1. So 0.5 and 1. And then this one looks like it is 0, comma 2. So 0, comma 2. And then the one over here, right here, that is 0, comma 4. So these are the vertices. This is important when we do the linear programming. Okay, so the next example we are going to look at will use this. So linear programming is a way to find the maximum and minimum for a function. Okay, so usually when we have a lot of different constraints, we have so many conditions, and we want to make something maximum or minimum. For that, we use a process, a method called the linear programming, where we deal with the inequalities. Okay, so let's look at this example here. A machine manufactures large and small containers. Large containers require 3 pounds of materials to fabricate, and small containers require 2 pounds, but the machine has only 24 pounds of materials. The machine can manufacture at most 10 containers at a time. Each large container can be sold for $7, and each small container can be sold for $5. How many of each container should be manufactured in order to maximize the income? So let's start with the variable. So let's go ahead and say x represents the number of big containers. And then let's say y represents the number of small containers. Okay. Now the last, so here it says the machine can manufacture at most 10 containers. That means x plus y cannot be more than 10. So maximum is 10. So it has to be less than or equals to 10. So we have one inequality here. And the another thing is x must be greater than or equals to 0. So even if we don't produce any container, it's 0 or it has to be positive. So it cannot be negative. Similarly, y has to be greater than or equals to zeros. Similarly, like the first one, if we produce something, we have positive number, otherwise it should be zero, non-negative for that. Now, the next one, the next equation inequality that we are going to get here is this one. So the large container requires 3 pounds of material. So if we are producing X number of containers, then 3x is the amount of material, plus the smaller one requires 2 pounds, so 2y. So the total amount of materials is 24. So this has to be less than or equals to 24. Now the income, okay, so the income, we have to write a function for that. Let's go ahead and write p of x, which is this, the larger one we can sell at $7, so 7 times x, plus the smaller one we can sell for $5, so it's 5 times y. So this function gives us the income. Now our goal is to say how many smaller and how many larger containers should we produce so that we make the maximum income. Okay, so for that, let's go ahead and grab these inequalities. So let's start with the first one. So we have x greater than 0, so it's to the right of y-axis. Y greater than 0, so it's above the x-axis. Now the first one is x plus y less than or equals to 10. That means the x-intercept is also 10, y-intercept is also 10. So we'll grab that here, and then we'll draw a straight line going through those 2 points. So that's the point. Now the other one, the other equation that we have here is this equation, 3x plus 2y equals 24. So the x-intercept is 8, because when we make y 0, we get x equals 8. And then the y-intercept is when we make x equals 0, we get y equals 12. So it should be up here. And then let's go ahead and draw this straight line connecting these 2 points. So if we draw this straight line, sorry, that does not, it's not really nice straight line, so I'm going to erase that. Sorry, I erased the first one. Let me draw that again. So the first one was 10 and 10. The second one is 8 and 12. Okay, that looks perfect. Now for the first line, if we take the test point 0, 0, what we get is, for this one, if we take 0, 0, so 0 plus 0 is 0, less than or equals to 10, that means it points down. And for the purple one, if we take the test point 0 and 0, again it is 0 is less than or equals to 12, so this one also points down. That means our solution is this region right here. Now we need to write the vertices of that region. So let's go ahead and write the vertices for this one. So the vertices are right here, which is 0, 0. And it's right here, which is 8, 0. The point right here is 4, 6. And the point right here is 0, 10. So these are the vertices. Now what we do is we'll check. We'll take the vertices, and then we'll find P of X for each vertices and see which one gives the maximum. So if we take 0, 0, and if we plug it in here, we get $0. So if we don't produce anything, we are going to make $0. Now let's take the next one, which is the next point here, 8, 0. And X is 8, so 7 times 8 is 56, plus 5 times 0 is 0. So we are plugging in here, okay, into our income function. So that gives us 56. And then if we take the next vertex, which is 4 and 6, and if we plug that in here, 7 times 4, 28, plus 5 times 6, 30. And when we add that, 7 times 4, 28, plus 5 times 6 is 30. So that gives us, that gives us 58. Okay. And then the next one, the last one is 0, 10. Now if we plug that in, x is 0, y is 10. So that gives us 50. So now if we look over here, the maximum that we have, the maximum value that we have here is this one right here. Okay, so 58 is the maximum. That means we will maximize the income if we produce. So income is maximized. So income is maximized if we make or manufacture 4 large containers and 6 small containers. And the maximum income is $58. So that's all for this video. We'll continue with another chapter next.